This is section 4.3 over rational equations. Excuse me. So what we're going to do here is we're going to be solving equations that obviously that contain fractions, and all I consider these to be are just glorified fractions. Now, this is going to be easy as to whether you have a good grasp of how fractions work. If you don't, then you might struggle a little bit. So I'm going to suggest that you go back and watch, um, some of the review material to help you out. So when you solve a rational equation, this is what a rational equation looks like. Now, a rational expression would look something like this. So without the equation symbol. So a rational expression is when you have a fraction that contains variables anywhere and numbers as well, okay? And the other part that you need to be very careful about is one of the things we're going to have to do is to look for an LCD, our least common denominator. And so when we do that, that can be a little tricky. For instance, if we look at this and we want to know what would the LCD be, well, the LCD, you basically go through and pick up everything that you need. So when I look at this, I see that both of these denominators have an x. So you might be thinking, well, I know my LCD has to be an x, and then I need to have this -2, so it's going to be -2x. But that's not true because this x minus 2 is a binomial. And when you have a binomial in the denominator, I always suggest that you wrap this in parentheses so that you are not tempted to break it apart. So now when you look at this, now there's a difference between x and x minus 2. These are not the same, okay? So anytime you have these binomials in the bottom, immediately wrap them in parentheses, okay? And so now they give you the steps on how to solve a rational equation. So number one, you want to factor the denominators of all the rational expressions. Identify any values for the of the variable for which an expression is undefined. Now, let's talk about this real quick because this is important. When we're talking about expressions, any expression being undefined, that means that we are not allowed to plug a number in and get a 0 in the denominator. So what we do is after you have factored everything, then you go through and pick up every denominator that you have. So I have this x minus 2, and I set it equal to 0. So this gives me x equals 2. And this x, when I set it equal to 0, I get that x is 0. So now if I were to plug a 0 into this rational, I would get 1 over 0, which would be undefined. And I can't do anything if something's undefined. This would just give me 1 over -2. 0 minus 2 is -2. So this would give me a -1/2, but this is undefined. So I have to be careful with any solution. If I were to solve this and one of my answers is a 0, I can't use it because this is undefined. Now, if I solve this equation and I get a 2, well, if you plug a 2 in here, 2 minus 2 is 0, then that makes this part undefined, even though you would get a fraction here. If you get one of these to be undefined, you cannot use that answer. So these two values, so x cannot equal 0 or 2. When we solve this, if our solution turns out to be one of these, I have to throw it away. And if you get two answers and they're both restricted like this, then you have to throw it away, and that means that it's a no solution. Okay? Now, excuse me. Number two, we identify the LCD of all the terms in the equation, and this is where you basically pick up everything that you need. Anything that you see in the denominator, you grab it. Okay? Multiply both sides of the equation by the LCD. This is going to clear your fractions. We solve the resulting equation, and then we check the potential solutions in the original equation. Okay? Just like let's see, we haven't gotten to it yet, but when we get to solving radical equations, you are going to need to check your potential solutions. You have to plug them back in to see what's going to work. And we have to do this because this is where you might get one of these restricted values. So you have to throw it away. So now they walk you through this example. So here's your equation. It looks pretty yucky, right? So here's an x plus 5. So I'm going to go ahead and put this in parentheses so that I won't be tempted to just grab part of it. Here's an x minus 5. Again, these are different terms. X plus 5, x minus 5 are different. And then this is a difference of squares, which factors into x plus 5, x minus 5, which is what they already did here. Now, when we identify the LCD, you go through and pick up what you need. This denominator has an x plus 5, so I need it. This denominator has an x minus 5, so I need it. This denominator has both of them, but notice how we already have both of them here. So we're good. This one is good. This guy's happy because he's in here. This guy's happy because he's in here. These two guys are happy because they're both in the LCD. Now, when you multiply both sides of the equation through by the LCD, your LCD is going to knock out whatever denominator that you have. So when we distribute, and this is what they did here, they took the LCD distributed to the first term minus the LCD distributed to the second term equals your LCD distributed to this other term on the other side. So notice how the x plus 5s go away. So you're left with 9 times x minus 5 minus, and then here our x minus 5s go away. So we're left with 6 times x plus 5. And then on this side, both of our terms in the denominator get knocked out with the LCD. So you're just left with the 15. Well, now this is a nice little equation. Distribute, combine like terms, and solve. But then you have to check. Okay, so you plug it in and you make sure that it works. Okay, and if it doesn't work, then you throw it away. And in this case, since you only had one answer and it didn't work, then this would be a no solution. Okay, all right, so let's actually walk through an example. So we look at number 1, and I only have one. I've got a denominator. I've got two fractions, but they each have the same variable. So my LCD. So this expression has an x in the bottom, so I need it. Now, even though this doesn't have anything in it, this is going to be affected by the LCD, and you'll see why in a minute. Now, for the 4 over x, well, there's an x in the denominator, so I need it. But look, we already have it. So I'm not going to make this x squared. I just have to make sure that my LCD makes everybody happy. Okay, so that's the case. So now we are going to distribute. I'm going to multiply the LCD to every term. So x times 1 over x minus 3 times x equals, and then here's my x times 4 over x. Now, if we do this correctly, every time, no matter what your LCD is, if you do it correctly, then you will lose your denominator is going to go away. Okay, so here our x is reduced, so we're left with 1 minus. Now, I have to multiply every term by the LCD, even if it doesn't have a fraction, because it's not fair to just multiply your LCD to this one, and then this guy doesn't have, is just left out. Everybody gets multiplied by the LCD. So that's a 3x. And then here, your x's go away to leave you with 4. Well, now we just have this nice little equation. So I subtract 1 from both sides. So this gives me a 3. And then we get x equals -1. And I did something that I totally forgot, cannot believe I forgot to do. And that was to check my restrictions. So my restrictions, in this case, we only have one, would be x equals 0 because you set your denominator equal to 0. So if my answer ended up being a 0, I would have to throw it away. Okay, but it's not. It's -1, and I can tell you that we're good. In fact, let's go ahead and plug it in. 1 over -1 is -1. So -1 minus 3 is a -4. 4 over -1 is a -4. So we get -4 equals -4, so it works. Okay. All right. Now, number 2. Again, we look at this and I notice that I have binomials in the bottom. So I'm going to wrap those up. Now I have 2 fractions and the denominators are the same. So my LCD, well, this denominator needs to have an x plus 1. This denominator needs an x plus 1, but we've already got it. Okay, so now we find our restriction. Since it's just one term, we're only going to have one value that's restricted. So we're going to set the x plus 1 equal to 0. And we get that x is -1. That is my restriction. So when I solve this, if I end up with a -1 as an answer, I have to throw it away. So let's see what's going to happen here. So I'm going to multiply the entire equation through by x plus 1. Now, when I distribute the x plus 1 to the 4, we're going to get 4 times x plus 1 minus, when I distribute to the second term, the x plus 1s are going to go away. They're going to reduce. They knock each other out. Equals, and then when I distribute to this last term, the x plus 1s go away. They knock each other out. And we're just left with the 8. Okay, so now we distribute. So 4x plus 4 minus 8x equals 8. So we get a -4x plus 4 equals 8. -4x, we're going to subtract 4 from both sides. So we get a 4. And then when we solve, we get a -1. But again, remember I told you, look at your restriction. That's why you have to find your restrictions. Since the answer that I got is it's my value that's restricted, I cannot use it. It's the only answer I got. So that means that my answer for this particular equation is going to be a no solution. Now, there will be some times where this is going to turn into a quadratic, which means you might have 2 answers. And then if one of them is restricted, then you throw the bad one away and then you keep the good one. Okay. All right. So let's look at the next one. So we have x plus 32 over x equals 12. Okay. Hang on. I need to remove some papers here. I've got too much of a stack. Okay. So my LCD, I only have one denominator and there's an x in there. So that means since I only have one value, I have one value that's going to be restricted. So my restriction is going to be that you set it to 0. And when you do, we get that x equals 0. So that's the value that's restricted. All right, sorry. Now, I am going to multiply everybody by my LCD, which is x. So now, x times x, that gives me x squared. When I distribute to this term, the x's are going to reduce, so I'm left with 32 equals, and then when I distribute all the way over to the 12, we're going to be left with a 12x. So I have an x squared, which means I've got a quadratic. In quadratics, remember that we have to set them equal to 0. So we're going to subtract the 12x from both sides. I'm going to put this in descending order, set it equal to 0. Now we're going to factor. I need two numbers that multiply to 32 that can get me a 12. So the x's have to go at the front, and that's going to be 4 and 8. And how do I get a negative 12 from 4 and 8? Well, they both have to be negative. And at the same time, if you multiply negative 4 times negative 8, we get a positive 32. So that's how we know that we're right. So this is going to give us a solution of x equals 4. And this gives us a solution of x equals 8. Since it's not a 0, these so far are good, but we have to plug it back in. So we have 4 plus, well, 32 divided by 4 is 8, and 4 plus 8 is 12. So this one is good. Now let's plug in the 8. Here's an 8. 32 divided by 8 is 4. 8 plus 4 is 12. So this solution is also good. So we get to keep both. Okay. All right. Now we start getting into these equations that are a little bit kind of yuck. Okay. So again, remember what I told you. If you have a binomial in the bottom, put it in parentheses so that you're not tempted to break this up. Okay. We need an LCD. So the first denominator has a y. Well, I need it. Now, this is why we put this in parentheses. So notice how the second denominator, it also has a y, but it's with a y plus 1. And this is different from just the y being by itself because this is a binomial. The y plus 1s go together. So we can't break that apart. And this denominator has a y in it, but I already have a y in my LCD. Okay, now for our restrictions. Now, I have two factors. I'm multiplying these two terms together, so I'm going to have two restrictions. This is just like when you solve a quadratic. When we do this over here, and we have to set each factor equal to 0 and solve, that's the exact same thing that you're doing. So we're going to set y equal to 0, and then y plus 1 equal to 0. And so these are our two restrictions, 0 and negative 1. So when I solve this, if I get a 0 or a negative 1 as my answer, I have to throw it away. Okay. Now, when we clear our fractions by multiplying through by the LCD, I'm going to do this the long way, but I won't do this all the time. So here's our LCD times our first term, which is the 16 over y. Minus, then we have the LCD y times y plus 1 times our second term, which is 16 over y plus 1 equals, then we have our LCD y times y plus 1 times our last term over here, which is 2 over y. Now, if we've done this right, our denominator should kick out with one of the terms in our LCDs. So here, the y's are gone. Here, the y plus 1s are gone. And for this last term, the y's are gone. So we're going to write what we have left. So we've got 16 times the y plus 1. That was left over from the LCD minus 16 times y equals 2 times y plus 1. Okay, so let's distribute. Whoops, I need the black one. So we get 16y plus 16 minus 16y equals 2y plus 2. This looks like an equal sign, so let me fix it. Okay. All right, so now we're going to clean this up. Well, hey, look, this is nice. The 16y's get knocked out. So we have 16 equals 2y plus 2. So I'm going to subtract 2 from both sides. So that gives me 14 equals 2y. I'm going to pull the y on this side, divide both sides by 2, which gives us y equals 7. Okay, now notice that it is not one of my values that is restricted. Okay, but we have to check our answer. Okay, so I'm going to grab my calculator real quick. Okay, so I don't expect you, whenever you check your work, I really don't expect you to do this, to do it by hand. You can plug this in your calculator and I'm going to show you how. So I'm going to take 16 divided by, let's put this in parentheses, 16 divided by 7 minus, open parentheses, 16 divided by, and then I'm just going to do this in my head, 7 plus 1 is 8. And that's the answer that we get. I don't care that it looks like that, okay? Because I'm going to check it against what it equals, which if y is 7, so this would be 2 divided by 7. And notice that we get the same decimal answer. Okay, so that's enough that tells me that 7 is the correct answer since the left side does equal the right side. Okay, and since it is not a value that is restricted, then we're good. 7 is our solution. Okay, all right. Now, number 5. Again, it kind of looks like, oh, these are getting worse. Well, kind of, but let's just see what happens here. So again, we have a binomial. We have another binomial, and then I have this trinomial. Now, when I have this trinomial, I have to factor it. But we're gonna work smarter, not harder. So here's what I mean by this. On a hunch, if you were to factor this, so I know that I would open my two parentheses, and the only way that I can get an x squared is if those are x's. Well, 3 only factors one way, and that has to be 1 and a 3. Huh. And look at these other binomials. You have an x and a 3 and an x and a 1. Well, here's an x and a 3, here's an x and a 1. And what do you think those signs might be? Well, if this is x minus 3 and x plus 2, positive 1 times a negative 3 does give me a negative 3. If this is a negative 3 on the outside and the inside gives me a positive 1, then I get a negative 2. Well, looky there. We didn't have to do much work when we factored that because there were our two binomials, okay? So now our LCD, we go through and pick up what we need. I need an x minus 3. I also need an x plus 1. And this last term, it needs both of them, which we already have. Okay, so now our restrictions, we have two factors that we're multiplying together. So we're going to set x minus 3 equal to 0 and then x plus 1 equal to 0. So we get a 3 and a negative 1. Those are my restrictions. So if my answers, one of my answers or both my answers come up with these, I have to throw them away. Okay, so now we are going to multiply everything through by our LCD. But remember, the purpose of this is to get rid of your denominator. So when I distribute to the first term, the x minus 3's go away. So I have x times what's left is the x plus 1 plus this term, the x plus 1's get knocked out. So we're left with 4 times x minus 3 equals, and then for the last term, the denominators, both of these binomials get knocked out. So we're left with x squared minus 2x plus 2. Okay, so hold on, because before you start thinking, oh my gosh, I have to factor that. No, you don't. What we need to do is clean up the left side. So we get x squared plus x plus 4x minus 12 equals x squared minus 2x plus 2. Now, we have an x squared, so you should be thinking, well, if I have an x squared, that means I'm probably going to have to factor, and you're right. However, when we have, let's go ahead and clean this up. Sorry, I'm getting ahead of myself. So this is x squared plus 5x minus 12 equals x squared minus 2x plus 2. Okay, so now if you're thinking, oh, great, I have this quadratic, so I've got to pull everything together. Well, watch what happens, because if I have to subtract, when I try to combine my x squareds, I would subtract them. And do you see what's going to happen? These x squareds are gone, which means if the x squareds are gone, we no longer have a quadratic. We just have this nice linear equation to solve. So I'm going to add the 2x to both sides. So plus 2x plus 2x, this gives me 7x minus 12 equals 2. And then I'm going to subtract, I'm going to add the 12 to both sides. So plus 12, 2 plus 12 is 14. And when we solve, we get that x is 2. Okay. And notice this is not one of my values that's restricted. So far, so good. So now I'm going to check. Okay, well, this one might be a little bit cumbersome. So in parentheses, we have x over x minus 3. So that's, we're going to check the 2. So that's 2 over, well, 2 minus 3 is a minus 1, plus, open parentheses, 4 divided by, well, 2 plus 1 is 3. And that's what we get. Okay. So now I'm going to do the top. Now we got to be careful here. So we're going to open my parentheses. Well, actually, yeah, let's do that. So 2 squared minus 2 times 2 plus 2. Then I'm going to close my parentheses. Then I'm going to divide that, open my parentheses. And then I have 2 plus 1, which is 3 times, and then 2 minus 3 is a minus 1. Close my parentheses. And notice how we get the same answer. So the left side equals the right side. So we're good. Okay. Or if you want to plug in by hand and work it out, man, knock yourself out. You do whatever floats your boat. Okay. All right. Number 6. So I have this binomial. So I wrap that in parentheses. And normally I would say, well, you've got a binomial here, and so let's wrap it in parentheses. However, look at what you have. Look closely at what this is. A squared minus 3a. So notice they have a common factor. And that's a common factor of an a. So when you take that out, you're left with a minus 3. Okay, so now for your LCD. Well, this denominator needs all of that. It needs an a and an a minus 3. And then when you look at this expression, well, this needs an a. Oh, well, there's already an a there, so we're good. And then this one needs an a minus 3. Well, we're good again, because there it is. Okay, so now we find our restrictions. We have 2 of them. So we set the a equal to 0, and then a minus 3 equals 0, which means a equals 3. So our 2 restrictions are 0 and 3. And again, I know you're Tired of hearing me say that? If one of your answers is 0 or 3, you have to throw it away. All right. So we are going to, let's see, I'm going to put it on this side. We are going to multiply through by a times a minus 3. So when I distribute to the first term, I lose my denominators, which is good. So that means we're only left with the negative 1 equals. Okay. So now when we distribute to the middle term, I'm going to lose the a's. Those are going to go away. So I have 1 times a minus 3. 1 times a minus 3. And then when we multiply by the last term, the a minus 3's are going to reduce. So we're left with a times a. Okay. So we've got negative 1. This is just a minus 3. And this is a squared. So we have the a squared, which means quadratic. So we've got to put this in quadratic form. So a squared plus a, and then I need to bring that negative 1 over. So I'm going to add a 1 to both sides. So plus 1, that gives me a 0. Minus 3 plus 1 gives me a minus 2. Okay, well, let's see. Let's see if this factors. So the only way that I can get an a squared is that the front of my binomials are a. 2 only factors one way. That's a 1 and a 2. How can I get a positive 1 from 1 and a 2? Well, the 2 would have to be positive, and the 1 is negative. And negative 1 times a positive 2 gives me a negative 2. So check. So now that means this is going to give me a solution of a equals 1. This gives me a solution of a equals negative 2. Neither of those are restricted. And so for purposes of time, actually, you know what? I don't remember. I don't have the answer key in front. So let's see. So 1 and then 1 minus 3 is a minus 2. So that's a positive 1/2. This is a 1. This would be 1 over a minus 2. So 1 minus 1/2 is 1/2. So 1/2 equals 1/2. Yes, that works. And this is probably going to work as well. So hold on just a second. Okay, so I went ahead and I checked the negative 2. So I plugged it in. And we did get that both sides equal each other. So yeah, they both work. So we're good. Okay. So they can be a little tricky, but again, practice, practice, practice. Okay. All right. Now for number 7, these are called literal. Again, we're back to literal equations. So we're solving for a specific variable. So when we look at number 7, we're solving for capital P. Now, when you have an equation like this, and you have, hang on before I forget, this should be a C. Okay, so when you have the same letters, except you have capital and lowercase letters, they are not the same letter. They represent different values. So you cannot treat them the same. Okay, so for number 7, we need to solve for capital V. Okay, so that means I need to get rid of the V that's in the top and the T that's in the bottom. Well, let's think about this for a minute. If I want to solve for P, well, P is being multiplied by V. And what, let me rewrite this down here. Okay, so capital P is being multiplied by, sorry guys, I dropped something. Capital P is being multiplied by V. So what undoes that is division. So we're going to divide by that. Now, the P is also being divided by T, and what undoes division is multiplication. So if I multiply the top and bottom by, or if I multiply by T over V on one side, then I have to do this on the other. And so on the left, notice that our t's reduce, our v's reduce to just leave us with a capital P, which is what we're solving for, equals big T, little v over big V times little t. And this is your solution. Okay? Now, I want you to try, well, no, because we're recording, so I'll go ahead and do this. All right, so now I notice, so we're back to kind of what we did before here. We're solving for A, but A is in the denominator, and I've got to get it out of there. So I need an LCD because I have fractions. So my LCD is, well, I need an A, and then I also need a B. So I'm going to multiply both sides by AB. So when we multiply AB times 1 over A, we lose the A. So all we're left with is B. And B times 1 is just B. Then when we distribute to the second term, I lose the B's. So all I'm left with is A. And then when we multiply times the C, then we multiply A, B, and C together. Okay. Now we are solving for A, but A, I have an A, B, and C on the right side and then an A by itself on the left. Well, I need to get them together. So all I'm going to do is subtract A from both sides. Now, when I have this, we need to be thinking, how can I pull the A out of both of those terms? So you have two terms and they have a common factor of an A. So hopefully you're thinking, oh, I need to factor out an A. So we're going to factor out the A, and then I'm left with BC minus 1. Now, how do I solve for A? Well, I have to divide both sides by BC minus 1. So the BC minus 1 on the right gets knocked out. I'm just going to flip this around. So we get A equals B over BC minus 1. And I know it's tempting. You look at that and see, ooh, I want to knock out those B's. You cannot do that because BC minus 1 is a binomial. It's all together. So you cannot just reach in and knock out that one part. Okay. All right. Now, number 9. Uh-oh. Oh, good. Okay. So number 9, we have this equation. And I went ahead and put the big R plus little r in parentheses, so we're not allowed to break those apart just yet. Okay, now they want us to solve for little r, but little r is in the denominator. Okay, so that means that my LCD, since I have one fraction, my LCD is big R plus little r. So I'm going to multiply both sides by big R plus little r. So that means I'm going to have capital I times big R plus little r equals, and then when I distribute to the second term over here, well, the denominators go away to just leave me with the E. Okay. Now, we need to undo all of this. Little r is inside the parentheses. So like an onion, let's start peeling things away. Well, I notice that the parentheses is being multiplied by I. So I can undo that by dividing both sides by I. Okay, so we're going to do that. So now these get knocked out. So we're left with big R plus little r equals big E over big I. Now, since I'm solving for little r, the only thing that's left for me to do is subtract big R from both sides. So these get knocked out. So little r equals big E over big I minus big R. And that's it. Sometimes people make this out to be a lot more complicated than what it is. And you may be looking at this saying, but it is complicated. You just have to get used to it. So if you treat all of the other letters as numbers and then solve for the variable that you need to, sometimes that helps. Okay. All right. Let's look at the next section. So now we're going to get into word problems. Okay. All right. Okay. So now we're going to talk about proportions. So we use proportions in geometry with similar triangles. So similar triangles basically means that you're comparing two triangles that have the same angle, but their lengths can be different. Okay, so if you look at these two triangles, their angles are the same. It's just that the lines have been extended, but the angles remain the same. And that's what makes them similar triangles. Okay. And so they label the angles. So we have angle A, B, and C, and we're comparing that to angle X, Y, Z. So angle A, it compares to angle X, is similar. Well, actually, they would be the same. Angle B is the same as angle Y. Angle C is the same as angle Z. But notice the lengths of the sides are different. Okay. And so as long as you are comparing the same sides, you're going to be fine. So when we look at number 10, triangle ABC is similar to triangle XYZ. We need to find B. Okay, well, notice that they gave us the same sides. They gave us this side of line XY, and line AB is 36, XY is 25, and AC is B. Okay, now, since I have similar triangles, I can compare their sides. So what we're going to do is we're going to say 30 feet or 30. We're going to compare it to 36. And then we're going to set this equal to 25 over B. Now, notice that I did not say 30 over 36 equals B over 25. If you start with this side first, then whatever you set it equal to, you better make sure that you stick with the same triangle. Okay? So notice that the numbers in the top belong to the same triangle. The numbers in the bottom belong to the same triangle. You could have said 30 over 25. Okay, I could have said, and I'm going to work this out both ways. I could have said 30 over 25. So this side over this side. Well, do the same thing over here. This would be 36 over B. Okay, now watch. Now here, we're going to cross multiply. Anytime you have a proportion equal, a ratio equals another ratio, this is a proportion, then we can cross multiply. So 30 times B. Okay, so 30B equals, now 36 times 25 is 900. Now let's solve for B. So 900 divided by 30, and that gives us 30 feet. Okay. Now let's try this one. So again, we're going to cross multiply, but look what we get. Do you see how we get the exact same thing? 30B equals, and then 25 times 36, well, that's 900. So again, B equals 30 feet. Okay, so you have to be consistent. You can't switch triangles. You have to stay with the same side. All right, now let's look at this next one. I did not change the name. This was the name that was in the problem. So Renee, who is 2 meters tall, wishes to find the height of a tree with the shadow 33 meters long. He walks 23.4 meters from the base of the tree along the shadow of the tree until his head is in a position where the tip of his shadow exactly overlaps the end of the tree's shadow. How tall is the tree? Okay, so this is what we're looking for. Okay, and we know that Renee is 2 meters tall. Okay, now I know that the distance from the tree to the end of the shadow of the tree is 33 meters. And he walked so far away from the tree to where the top of his head, the shadow from the top of his head, aligned exactly with the end of the shadow from the tip of the tree. I don't know this distance. I know the entire distance is 33. He walked 23.4 meters away. Well, we can figure out what's left. So all we're going to do is take 33 and we're going to subtract 23.4. So we get 9.6. So this is 9.6 meters. Now, notice that we have similar triangles. Here is the larger triangle. This is the tree. And so we don't know this, but I do know that the base of this triangle is 33 meters. And then we have the smaller triangle, which is Renee. And this is, he's 2 meters. And I know that this is going to be 9.6 meters long. So you have similar triangles. So you can say, we can call this X. So I could say X over 2 equals, now since I started with this triangle, then my next proportion would be 30, my next ratio would be 33 over 9.6, or you could have said X over 33. So this side over that base has to equal this height, 2 over 9.6. But again, look what happens when you cross multiply. 9.6, X, 9.6X equals 66. So 66 divided by 9.6, we get X to be 6.875 meters. Okay. So that's how tall the tree is. And then again, if we do this over here, notice that we get the same thing. 9.6x equals 66. And again, we already solved that to get 6.875 meters. So you just, again, you want to be consistent with how you set up your proportions. Okay. All right. Now let's look at number 12. We're only going to do 12 and 13. I'm not going to do the last two. All right. So solving applications involving uniform motion, distance equals rate times time. Okay, let me raise this up a little bit. All right, so it says Danny and Dana agree to meet in Chicago for the weekend. Danny travels 205 miles in the same time that Dana travels 175 miles. And this is important. That's why I highlighted it. If Danny's rate of travel is 6 miles per hour more than Dana's, and they travel the same length of time, at what speed does Danny travel? Man, that's like a whole lot of information. Okay, well, take it step by step. Let's fill in what we know. Okay, so blah, blah, blah. Danny and Dana agree to meet in Chicago for the weekend. Okay, blah. I don't need any of this. They're going to meet Chicago for the weekend. Big deal. Okay, Danny travels 205 miles. That's his distance. So Danny, his distance is going to be 205 miles. In the same time that Dana travels 175 miles. So Dana traveled, her distance was 175. If Danny's rate of travel is 6 miles per hour more than Dana's, stop. This is important. Let me see. Let me get a different color. Danny's rate of travel is 6 miles per hour more than Dana's. So in order for me to know how fast Danny is traveling, he's traveling 6 miles per hour more than Dana or faster than Dana. That means I need to know what Dana's rate is. How fast is she going? Because for Danny, well, he's going 6 miles per hour faster than whatever Dana is traveling. So that's x plus 6. Okay. And they travel the same length of time. At what speed does Danny travel? I have nothing else to fill in. Well, shoot, I don't have any more information, or do I? So uniform motion is distance equals rate times time. Now look, if distance equals rate times time, notice that we don't have anything to fill in for time. But look, if I take this and I solve this, I solve D equals R times T. If I solve this for time, then I'm going to divide both sides by the rate. So that means that T is going to equal the distance over rate. So let's fill that in because that gets us, at least that gives us something to plug in. So distance over rate. Distance over rate. Now, I highlighted this. Danny travels 205 miles in the same time that Dana travels 175 miles. So that means that Danny's time has to equal Dana's time. Now, remember when we first started looking at word problems, one of the things that was a suggestion was that you create a verbal model. And this is why that verbal model is so important because it can help you set up your equation in order to solve the problem. Okay, so since I know that their times have to equal each other, then you have what to fill in for Danny's time. Danny's time is 205 over x plus 6. And that has to equals Dana's time, which is 175 over x. Okay, well, look at what you have. Here's a little binomial. Now, I could solve this by finding the LCD, but sometimes that can be a pain. But here we have a ratio set equal to another ratio. This is a proportion. So how do we solve proportions? Just like we did earlier, we solve proportions by cross multiplying. So it doesn't matter which one you set up first. So I'm just going to say 175 times x plus 6. So this has to equal this, 205x. So this is 175x plus, now be careful, 175 times 6 is 1050. And that equals 205. Now I need to move my 175 over. So I'm going to subtract 175 from both sides. So 205 minus 175 gives us 30x. We're solving for x. So I'm just going to move the x on the other side. So 1050 divided by 30, we get 35. Now, what did we just find? Who is x? Well, that's Dana's rate. So Dana traveled at 35 miles per hour. Okay. Now it feels like, man, that was a lot of work. I'm glad we're finally done. Well, no, we're not, because we need to answer the question that said, if Danny's rate of travel is 6 miles per hour more than Dana's and they travel the same length of time, at what speed does Danny travel? They want to know what Danny's speed is. So Danny's speed is going to be 35 plus 6, which is 41 miles per hour. And that's my answer. That's our answer. Okay, so it's not enough to just set up your equation and solve for x. You have to make sure, excuse me, you have to make sure that you are answering the question. Okay, all right. Now, the last one, this is the last one we're going to do. And so we're going to try to get through this as fast as possible. Now, this is going to start out just like number 12. Okay. Okay. So it says, excuse me, Mateo travels 60 miles to an island and 60 miles back again. However, during the trip back, the boat lost one of the engines and his trip back was 5 miles per hour slower on his way out. I'm sorry. He lost one of the engines and his trip back was 5 miles per hour slower than on his way out. If the total trip took Mark 7 hours, find the speed going to the island and coming back from the island. Okay, so going to the island, so going, and I know it says to and from, but I just want to write this in just to make sure. So going and then return, because they also use those words going and return. So we want to make sure that we're plugging in correctly. Okay, so it says he travels 60 miles to the island and 60 miles back again. Well, that makes sense. If you're going to an island, you know, unless you're going to make a pit stop somewhere else, your distance is going to be the same. Okay, so that's what I know. Now it says during the trip back, the boat lost one of the engines and his trip back was 5 miles per hour, 5 miles per hour slower than on his way out, on his way going. So the trip back was slower. His return trip was slower than it was when he was going. So that means X has to be his rate when he was going, because when he was coming back, he was going 5 miles per hour slower. Okay, so the only other thing that they've given us about time is this. It said if the total trip, okay, that's different. Last time they said that the last example we did was Danny and Dana, and that they traveled in the same amount of time. But here it says if the total trip took Mark 7 hours, well, that means going to the island plus coming from the island. That makes the total trip. And all of that took 7 hours. Again, this is where the verbal model comes in very handy. Okay. So now, just like we did earlier, I don't have anything to fill in for time other than I know that this plus this has to equal 7. So if distance equals rate times time, let's divide both sides by the rate. So we get that time equals distance over rate. So this is going to be 60 over x. And this is 60 over x minus 5. All right, so to the island is 60 over x plus coming from the island is going to be 60 over x minus 5, and that has to total 7. Okay, now remember, this is a binomial, so we have to put that in parentheses. Okay, now, actually, you know what? Let me make some room here. Oh, that's coming off. Sorry, I had to use a sheet from something else. So I had to use a lot of whiteout. So this is x minus 5. I'm going to put this in parentheses. Okay. All right. I think we're good. Okay. So now our LCD, we're going to pick up everything we need. So our LCD, I need an x and then I need an x minus 5. So I'm going to multiply everybody by x times x minus 5. X times x minus 5. X times x minus 5. Okay, so now for our first term, the x's are going to go away. So we're going to get 60 times x minus 5 plus here, the x minus 5s are going to go away. So we're just left with 60x equals, and then over here, we're going to get 7x times x, that's 7x squared. 7x times a negative 5 is a minus 35x. Okay, so we're going to clean this up. 60x minus 300 plus 60x equals this 7x squared minus 35x. Okay, so now as we clean this up, we get 120x minus 300 equals this 7x minus 35x. Now we have a quadratic, so 7x squared. We're going to subtract 120 from both sides. So that'll be negative. So 120 and 35 is minus 155x plus 300 equals 0. Okay, now we have this horrific looking quadratic. Okay, now I will tell you, excuse me, didn't mean to burp in the recording. Okay, so what I will tell you is this will factor. Okay, now you can decide, do you want to spend time trying to factor this, or the last thing I would do is complete the square. So your other option would be using the quadratic formula. It's up to you. So I think I would go ahead and at least try to factor it. So if I try to, I'm just going to try it twice. If it doesn't work, then I'm going to jump to the quadratic formula. So 7x squared only factors one way. So that's an x and a 7. Now for 300, I'm going to look for factors that are close together. Okay, so 12 times 25 is 300. Okay, so I need to see, can I possibly get 155? Okay, so the outside is going to give me a 25. And then 12 times 7 is 84. Ooh, kind of close. That's 109. I need 155. Okay, well, let's keep 12 and 25, except this time, let's flip these around and let's see what happens. So let's say 25 and 12. And honestly, guys, I really don't remember the answer to this. So the outside, okay, so this didn't work. Okay, so I know the outside's going to give me a 12. And then 25 times 7 is 175. Let's see. So if I subtract them, I get 163. And if I add them, I get 187. Okay. Well, bummer. That was really, really close. So let's see. Let's take 300 divided by, it's not going to be divisible by 13. 300, is it divisible by 14? Nope. 300 divisible by 15, 15 and 20. Okay, so let's try, and this is the last one that we're going to try, is 15 and 20. Okay. So let's just put that in exactly as this came up. Whoops. Well, there's a 2. We'll do that. We'll do 20 and we'll do 15. Okay, so that's 144. I'm sorry, I can't believe I said that. 20 times 7, that's 140. And then the outside gives me the 15. Ah, that's 155. That's what I need. And how do I get 155? Well, these both have to be negative. So there we go. Okay, so this x minus 20 equals 0. So that means that x equals 20. And then 7x minus 15 equals 0. So 7x equals 15. X is 15 sevenths. So that's this would be 2 and 1/7 miles per hour. Okay, so now we need to see which one of these would work. Well, let's go ahead and take this one since I just figured out what 15 over 7 is. So if this is a little over 2 miles per hour, this is our rate. This is our x. Well, it would work here. He would be going really slow. But when he comes back, if he's going 5 miles per hour slower, well, let's say that it was just 2. Well, 2 minus 5, that's going to give me a negative answer. And we can't go a negative rate. So this is not my solution. So it's going to have to be the 20. So that means what we just found out is they want to know the speed going. So going to the island is going to be 20 miles per hour. And then coming from the island, he ended up going 5 miles per hour slower. So we just subtract 5 from that, which is 15. And there we go. Okay, that one was just yucky because you had this horrible looking quadratic, but you could have gotten out of it by using the quadratic formula and just be very careful when you're plugging that in. All right, so that's it for section 4.3. That was a pretty intense section, so make sure you go over that. You are going to have problems on the test. If you got any questions, let me know.